Hello, this is Dr. Dave Maslach talking about reciprocity.com, and the E is spelled with a 3. So actually today I want to talk about my series on being a total nerd. It's called Nerd Out Wednesdays. I'm posting these every week, and it's about words and science. And I really wanted to talk about the average effect because I think this is a really important concept that the vast majority of the people out there don't really get. Even a lot of scientists make this mistake. In fact, it is very, very common when we try to understand scientific studies. So what is the average effect? Well, the average is a really, really important concept in science and in just in general in terms of making sense of the world. It really, truly is. An average, which is sometimes it's referred to the mean. I'm not going to get into that, but I just want to say a general idea of what the average is where you have, imagine that you have a sample, and I'm not going to get into all the details and all that kind of stuff. Who cares about that, right? What I want to describe is what an average is to just sort of the intuitive understanding. That's what you'll find with these videos that I put up. Try to give you some of the intuition that I have. So an average is, if you imagine you have a sample, so you collected a bunch of data on something. So you've collected a bunch of data on a bunch of people in some population. That's called a sample, where you have, let's say you have 30 different people in a population. So what's a great what's a great sample that has 30 people? Well, it's a classroom, right? So you have 30 different students. Each one of those students is a little bit different. In fact, a lot of students are a lot different in the classroom, right? Like they're totally different. What you try to do with an average is you try to get the central tendencies of some particular feature across all of these different people, right? So for example, scientists might be interested in age, for example. We look at the age across all the different students, all the different people in a classroom. And what you will find is that there is an average age. There's an age, say a classroom of undergraduate students. There's some people that are 17 years old, some people are 22 years old, some people are 21 years old, but you will get what is called a central tendency towards maybe it's 21 years old. It's usually in the middle of this sample is the central tendency. And the central tendency is what's referred to, and I know that there's different terms and all that kind of stuff, but I'm just going to say it's the average. And that average is what we're trying to explain in science. We want to make sure that we're trying to explain that it's a hypothetical person. It's a hypothetical. It doesn't exist. It is something in the middle. There might be one person or two people that are very close to this very this middle tendency, but in general, the sample that you collect, all the different students, that doesn't necessarily explain them. It explains them just a little bit. It explains that sample enough. Or that average explains a little bit of each different person in that population, right? So some people are close to the age of 21, some people are a little bit older, but in general, we can get what is called the average towards the average age, right? So it's it is the closest that explains absolutely everybody in that population. And this idea is central to not only, it's central to a lot of different parts of science, not only in terms of methodology, but it's central in terms of understanding how, so for example, in psychology, how people learn, we often think about these sort of averages. In business, we think about these averages. And what we're trying to get at is this hypothetical ordinary person. So this is really important because then that explains what is the average effect. The average effect, remember, if you look at the previous videos, I talk about what we're trying to do as scientists. We're trying to get the independent variable. We're trying to look at the independent variable and how it affects the dependent variable. But what we're trying to do is look at this effect for the average person. So if the average amount of the independent variable goes up by a certain amount, what is the average amount? It's going to affect the average dependent variable for the average person. So what's really interesting is we're trying to get kind of the explanation that is kind of blanket across everybody. It doesn't explain everybody. It truly doesn't explain everybody, but it explains everybody just a little bit. And to some degrees, it explains a little bit more for somebody, and then for some people it explains a little bit less. So here's the thing that everybody gets wrong, and this is very important, that when you read a scientific article, we often attribute and we often think, well, this is across this particular effect that we see is across everybody, and it's going to affect everybody equally the same, right? So when I read a scientific article, and for example, I might read that smoking causes cancer, right? Some article, and it's not going to say that, right? That's just, but I'm just generalizing. I know that there might be some cancer researchers out there, so you can beat up on me if you want, but I'm just generalizing, right? So there might be an article that says smoking causes cancer, and the problem is when I read that, I cannot make the prediction. I can't necessarily suggest that it's going to affect me the same way. This is the attribution error that we often get. People often see a scientific study and they'll hear that smoking causes cancer, but then they say, well, I've been smoking for 30 years or I've been smoking for 40 years and nothing has happened to me. Well, that is not what we're measuring in a scientific article. What we're trying to measure is the average effect across many different people. So some people, it's not going to affect them. My grandpa, I think he was, I want to say he was 86. I might be wrong, before he passed away, but he was very, very, he lived a long time, and he smoked every day. I remember going in, and he was into his house. They had a pretty small house, and he'd always carry, he was World War II vet, he'd always carry a pack of smokes in his sleeve up here. For those of you who remember that was a big thing. He always have a pack of smokes there, and he was smoking them all the time. I don't know how many packs of smokes that he smoked every day, but it was a lot. And he lived until he was a very, very old age, and he never really had anything that was affecting him in terms of cancer. But if you generalize based on that result of him, he could be a complete outlier. He might have some sort of weird genetic code that allows him to not be affected by cancer. So you have to really, really be concerned about this. You have to look at this. This is what we look at, is the average effect. And any scientific study that's out there, most of them are looking at this average effect for this imaginary hypothetical. It doesn't exist. This average person that has these very average characteristics, right? So that is really important, that insight of what we're just looking at, these sort of generalizations across many different people. And often we get, it doesn't explain a lot, and that's totally normal. What we often get are, maybe it explains 3% of every single person in that sample. Maybe it explains 10% of every single person in that sample, and that's fine. That's actually great. That's a pretty good scientific article if you can explain 10% of something across many different people, especially if you get larger and larger and larger sample sizes, right? As you get thousands of people in your sample and making generalizations across thousands of people, then that's great if you can explain 10% of somebody and something in that population. So that's incredibly important, and you have to be very cautious when you start interpreting scientific results. Not only cautious in the sense of generalizing them to your own experiences, because that's what we're looking at, is this hypothetical ordinary person, but as well as when you start hearing other people saying, well, that's a silly study, that doesn't make any sense, because I know X and X a person, or I know this and this and that, and it never happened to them. Well, that's not what we're looking at. What we're looking at is across we're looking at across everybody, and we're trying to get this average effect across everybody. It's so incredibly important. So if you like these videos, I'm going to put out stuff about science and words in science every Wednesday. That is, I have a goal to do roughly 120 videos about these kind of things. So if it does happen, that's great. And if you like this kind of other videos, if you like this specific video, do the old thumbs up, ta-da! Or you can do a if you don't like it, that's totally fine. It's okay with me. And if you want to look at other videos, I post things about writing as well as science. I do lots of stuff on science and being a doctoral student as well as, so I'm a professor of innovation and strategy. So I talk about business as well and innovation, so you can look at some of those videos. And lastly, if you're interested in this reciprocity project, it's a sharing economy proofreading platform that I'm trying to build, where you can go online and you can get free proofreading if you want, as long as you're within the system. But then if you want to take credits out and convert that into cash, it's going to cost, there's going to be some sort of fee associated with that. It might change. I don't know. So I don't want to give you a number right now. But you could check that out as well and see what I'm doing. And that's going to help out science too, which is really, really cool, that I'm excited about, is that that allows me to, do some really cool experimental stuff that we couldn't possibly do before. You can look at some of the older videos and I explain what that I'm doing there. So that's all I wanted to say. And thank you so much for listening. You are awesome for listening. You're so cool if you subscribed. Thank you again, and I will see you on the next video. Bye. Take care.